Hi there. A few days back, I got an email from Stability AI announcing their stable virtual camera. I wanted to give it a go. Too long, don't read. I went through the Windows install, and after downloading, fixing a few things, putting in some credentials, and downloading 10 KB of stuff, it wanted to download a Windows exe, and the virus guard said no. Now, I did investigate this a bit to see if it was safe. An initial look was that 4 years ago, two virus guards said the file wasn't safe. So I figured if in 4 years they can't fix this, so it might be a bit wrong. I could have just ignored it. If I do, why am I paying for virus guard? Or I could use a solution that I was preparing yesterday and haven't done the video for yet, which was to install the whole thing in Docker and run it from there. So if you're interested in that, stick around. So welcome to Grandad Does Stuff. This is going to be a series of videos looking at stuff I'm interested in, which is going to be around photography, imaging, and computing. I'm not ready to launch a channel yet, but I really wanted to share this with you while it's fresh. All the links will be in the description, so come with me and let's do some stuff. Right, so this was the email I got sent. So it's the email up here, the web version of it. What's new in Stability AI? Stable virtual camera is here. This is a multi-view diffusion model that transforms 2D images into immersive 3D videos with realistic depth and perspective. And you can see this video playing down here. There's a link to it up there. And if you click on that link, you come to this page here, and we get a slightly bigger version of the video that's playing, and a whole lot of blurb and links to all the other license. There's a paper, the Huggingface page, and GitHub. So basically the thing is, you put a static image in and it's kind of a walk around of the image. So this one I like. You've got all the reflections in the mirror happening. Here's the zoom in and the perspective on the Milky Way changes. This dragon, they kind of have an orbit view and they kind of wander around and see the back of the dragon. Here we've got kind of a multi orbit around here a couple of times, looking at the back of these telephone boxes as well. That's what I thought was interesting enough to run. So if we go to the Hugging Face page, it's a gated model, which means that when you first come to their page, with a bit down here, say if you want to use this model, you have to click here to get permissions. A form pops up. Read all the stuff, agree to the permissions. If you do, click the button, and then you'll have access to it. Later on, you're going to need an access token, and I'll show you that when we get there. So what else have we got here? They've got their Stability AI stable virtual camera GitHub page. It tells you how to install it. Git clone, change directory, pip install, Hugging Face login, run the demo, and you'll see all those steps later on. Then I've got my Grandad Does Stuff GitHub page. So all links will be below. In here, there's a stable virtual camera directory, and this will show us how we get to a Docker image, and we can run all this in Docker without having to fight with the Windows virus guard problems. So I'm going to show you this in PyCharm. There's only 3 files in that directory. So there's a README file here, which has got quite useful. It's got some notes and objects at the front, but it's got all the commands you'll need down here. And as is in PyCharm, it's got a little executable symbol next to it. It's got the Docker file for it. Now, I couldn't take us all the way through the process because I had to put the Hugging Face token in. So this bit gets us to a point where we can do that. Then we download a few more bits. Then we can save and reuse the file that we have later on. So this is from an Ubuntu 2004 image, a little old. I've added a user because I don't want to run everything as root. I'm just installing a whole bunch of things. So update, upgrade, everything up to spec. Remove the Python 3.8 that comes installed with it. Then we've got curl and some software properties, which enables me to add at the repository dead snakes, which in turn enables me to add in Python 3.10 and the dist utils, Git's going in there as well. A couple of symbolic links, so we can use Python and Python 3 rather than Python 3.10 as our access into Python. Then we curl pip into Python, so we've got access to that. Then we upgrade it to make sure it's the latest version. And then we're doing an install of a lib, which we also need on here, otherwise it doesn't work. Change that user, change to the user's directory, and configure the credential helper, because when you do the Hugging Face CLI login, put your token in, it's the Git credential helper that's going to store that for us. And then we're going to install the stable virtual camera from their repo. So these are the commands we had there, as git clone, change direction, and install dependencies. I found one of the dependencies was broken, so I just writing the fix for that in there. Now, when you build this, you're going to do a Docker build. We want to know what image is going to save it to, rather than just having a random SHA. And I've called it stable virtual camera build. And I've just run one of these in here, and it ran in about 6 or 7 minutes on here, who are 351 seconds, or is that 6 minutes-ish? Not quite a true reflection, because it started about here, about the user line. So there's another few minutes before that. So it's going to take 15 minutes or so to run through the whole lot. And it's going to create this image stable virtual camera build. I've got a Docker Compose file here. So I'm going to do Docker Compose up stable virtual camera build, which is this service here. Uses the image I was just talking about, gives it the stable virtual camera build as a name, yada, yada, yada. And we've got a command here, which just means it's going to spin forever. So I can log into that and do stuff with it. So let's start that image up. Compose up, that's the command I want. And here it is starting up, and that has started. And now I'm going to log into it. So it's a Docker exec. I'll log in as a user. I'll log into that build service just with a bash shell. That's there. So we need to go through the next steps. So first thing, we need to drop into the right directory, which takes me there. I need to do a Hugging Face login, which is that one there. A slightly strange path. It installed it, the CLI, in a path that's not on my system path. So I've just spelled out the full directory. You only ever do it once, so let's not be too bothered about that. I have to put my Hugging Face credentials, so I'll show you how to get the Hugging Face credentials. Let's come back to Hugging Face. So I'm coming here into my profile, settings, access tokens. I will create a new token. I'm probably just going to just create a read base token there. I will give it a name. I'll delete me, because I will delete it after this has gone through. I create the token, copy that. I'll leave it on there in case I want to come back to it. So it says add token as a Git credential. I'll say yes, either case will do. And it says the current active token is delete me. Next thing I need to do is do the Python of the demo Gradle project. And that will come through here. And again, this is going to take a few minutes, because when it's warmed itself up, it will download a config file at 450 bytes, which is easy. Then it's going to download a slightly bigger file. They're a mere 2.28 gigs. But then it downloads the real model from the Hugging Face page, which is another 5 gigs. So that is going to take a time. Okay, I'm going to let that download, and I'll come back to you when that's done. So I've shut this down, or stopped recording for 20 minutes or so. It's done a fair bit of download. This was 2.3 gigs, another 5 there, another third of a gig there, another 4 gigs here, which is just coming to an end. So hopefully that's the end of it. So in total, that was 10, 15 gigs, a fair amount. Here we are. This is run all the way through. Even give me a public URL. So I'll just click on that, prove it all works. always worrying whether these things work or not, but yep, here it is. Not run that one just yet. I'll show you why. I will show you the thing actually working properly in a short while. Now, this is where you have to be very careful, because if you shut things down in the wrong order and clear things out, you're going to waste all that hard work. So here, because the service is going to run anyway, I can shut down the Gradle server that I've just started up that's running the program. So I can shut it down. I'm pressing Control-C. It is not listening to me. Here we are. That's gone. I'm now logged in to the virtual machine, or the container. So I do ID, I'm a Unix user, but I can exit out of that as well. So I'm now back in Windows. If I do Docker minus Docker PS, all right, my container, stable virtual build, is still running, which is exactly what I need. Now, I'm not going to run this next command because I ran it before. And when I ran it before, it had my private Hugging Face detail token in there. This got the public one in, so I'm not going to save that, and I'm going to delete that token you've seen as well in a minute. But you run docker commit stable virtual camera build, which is this name here, and then you're going to save that as stable virtual camera 1.0.0. And what this does is, it, rather than building a Docker image from a Docker file, you can take a running Docker containers image as it currently is and save that as a the image that we're going to build. If you can take the current running containers state and save that as the image. So that's what you need to do. So I'm not going to do that because I've done that before. I'm just going to shut this one down. And it will shut down any second now. Let me find my Hugging Face tokens, which are over here, and I shall go and delete my delete me token. So that is no good to anyone. Okay, that is history. Okay, so that has gone down. Now, I can start that up again anytime that I want by doing docker compose up stable virtual camera. So that links back to my Docker compose file, stable virtual camera. So the image it's using is stable virtual camera 100, which is that one we just saved from the image we built and then put our Hugging Face details in and downloaded all those weights into. The container name will be stable virtual camera. I'm going to use a standard user. I don't want to have an elevated user. I'm going to create a link that goes out to the public internet. So we're going to try and get as much protection in the way as I can. We've got a working directory, which is my user into the stable virtual camera directory. And the command, rather than this normal spin one, I'm actually going to spin up the Python demo Gradle project, which you saw flash on the screen very briefly. There's a last bit here, which is about plugging my NVIDIA graphics card all the way through from my PC to the inside of the container. So this is really going to run on my hardware that's out there. So to start that up, I need to do docker compose up and just give it a stable virtual camera, which I will do now. Before I do that, just do a docker. Yes. Yeah, and it's got a drone runner and a Pi hole, so it's nothing interesting running there as far as we're concerned here. I'm going to start this stable virtual camera. I haven't got the -D on it here, so it starts it up in the command line, so we'll see the login come out of all of that in a moment as it starts up. Right, and here we are. So when we built this thing, put our Hugging Face details in, it downloaded about 15 gig of stuff. So it took a few moments for it to actually load all that stuff in, but it's now finally come back and it is all running. I haven't yet had any success in getting through to it on these internal IP addresses, just trying to map it through and get it all started up because it keeps claiming the addresses in use. I just haven't had a few minutes to try and sort that out. But you do get this public URL one here. So I click on that. Again, as we saw before, and the other ones there and dead, the image does come up. Let's just prove this is all working. We'll take one of these images. I quite like that dragon one. There it is. You have to click pre-process image. Let me press it again. Oh, here we are. I didn't press it in the first place. So I'll press render video. So first pass sampling, and this will step through, and it takes a few moments to go through. Now, the interesting thing to look at while that's going on, warning's got high GPU load. That's a warning from NVIDIA broadcast. If I come into my task manager, you'll see the GPU here running 87%. I'm a little surprised by that because when I ran it earlier, I chose a different image actually, and they actually flattened my GPU out at 99%. So it's definitely being mapped all the way through from the inside of that container, all the way through to the GPU. So we're running on some decent hardware at least. So here we are, it's just about to finish the render. What's that taken? 2 minutes or so. We've got an output here. And it's pretty much that fly path we saw in the video. It's pretty jumpy. I mean, and I think that's the first render. I think it goes through to the second pass stuff and it fills it in and makes it a lot smoother. That's 3% through in 30 seconds. So it's going to take a good few minutes to get through. So, right. So this little dragon's been spinning around now for about, 710 seconds or so, 12 minutes or so. It's just about finished. The second pass sampling at 100%. So I'm expecting the video to come in any second now. Oh, and here we are. So it's only a 2-pass system. We've got quite a smooth video rotating around. I think the wing kind of moves position slightly on the back and comes detached at one point. I think the head nods slightly gently at one point as well. That's pretty impressive from a single image there. I'm starting to see some better image generation stuff coming out of the large language models. I'll be looking at those in future videos, I expect. Still high GPU going on. But anyway, that's all I had for today. The key thing was to run this stable virtual camera in a container rather than the raw Windows, just means it's not polluting the rest of your Windows environment. So I had a particular problem with that virus guard trip up I had. Now, I guess you could try out any other kind of models you want in this containerized world and map it all the way through to your GPU, to you running at full speed. So anyway, thanks for listening. If you liked it, like and subscribe. A bit early, channel's not really running yet, but hope to see you again soon. Take care.